All right, getting started with one variable statistics. This is part one. One variable statistics covers a lot, so I wanted to split it into two videos for you. I'm going to first talk about what we're going to see in this video, and then I'll go into more depth, and then we'll do some practice problems. So between this video and the next one, we're going to be talking about measures of center, measures of variability, measures of position and outliers, skew effects, graphs, and cubs. Remember, cubs is our acronym that helps us remember how to describe quantitative data. Some ideas, and we'll go a little bit more in depth, and then I'll go super in depth. Between these two videos, we're going to cover measures of center, which is mean, median, and mode, and what they represent. Measures of variability, which is standard deviation, interquartile range, and what they represent. Measures of position include percentiles, quartiles, cumulative relative frequencies, and then that 1.5 times IQR rule, which you probably will remember is our rule for determining if a value is an outlier in the data set. Then we've got some skew effects, and then we've got the how skewed data affects measures of center, measures of variability, and then we've got graphs and cubs, so that way you can be interpreting, describing, and comparing graphs of one variable data. I'll make sure I talk about categorical data when we're doing that as well. All right, so that's what we're going to cover between these two videos. Let's get started on what we're doing in just this one, though. So the first thing I'm going to look at is measures of center. So the first one's the median, which you probably are remarkably familiar with. The mean is something that you're very comfortable with. It's what you think of when you hear the word average. It's the sum of the data divided by how many data points there are. So if you take up every observation, add them up, and divide by how many there are, that's what we call the mean. So I've got that written as a formula in that second bullet. We call it X bar if it's sample data, and in the parentheses you can see it's denoted mu if it's the population data instead of the sample data. The median is the physical center of the data. We don't really have a special symbol for that. We just say median. In a small data set, just arrange the data, count into the middle, sure. Or maybe if you have the data set, you can just enter it in your calculator and do one variable statistics, because your calculator is amazing and will do that for you. Conceptually, though, for example, if I have a data set where n equals 100, which I see right here, right? If n equals 100, the median is going to be the average of the 50th and the 51st data point, because that would be the dead center observation. I want to look at if I have like n equals 101 too. So if I cut 101 in half, that's 50.5. In which case I would just round up. The 51st observation in that case would be the median. So that's good for these conceptual questions that the AP exam likes to ask a lot, and I'll have an example of that towards the end of the video. The mode, that one's super easy. It's just the one that you see the most. The mode is the most frequently observed data point. Again, no special symbol or formula. All right, measures of variability. First one, the one that we talk about constantly, we use it so much, is the standard deviation. It's denoted as S if it's the sample data, sigma if it's the population data. The way that we interpret this is the typical distance from the mean. It changes based on your context. Make sure you always include context. But standard deviation is the typical distance from the mean. The more spread out the data, the higher your standard deviation. The more clustered your data, the lower the standard deviation. IQR is the difference between the third and first quartile. So remember, the quartiles separate a data set into 4 equally sized pieces. Now they might be different widths, but they will contain the same number of observations. And that's a concept question that they like to play with a lot. They contain each quartile contains 25% of the data set. The interquartile range is the difference between Q3 and Q1. So that's going to be your middle 50%. So it's the range of the middle 50% of the data. And then we've also got range, which is just the plain old difference between the largest and smallest observations. Please be very careful to not say on the AP Stats exam that the range is from 13 to 21. The range is a single number. You would say that the range is 8. You wouldn't say the range is from 13 to 21. So make sure that you're very careful about that. And with that, we're in some problems already. Consider a data set of positive values, at least 2 of which are not equal. Which of the following sample statistics will be changed when each value in this data set is multiplied by a constant whose absolute value is greater than 1? So I'm just saying, which of these will change? So let me draw like a made-up distribution. I'm going to end up drawing a normal one, a really, really terrible one. Maybe that's more chi-squared. But anyway, I've got my distribution. Um, it's a density curve. And then I'm just going to go, okay, it's centered at, let's say, 2. This is 4. That's 6. That's 0. And let's call that -2. So this is a really terrible distribution, but whatever. It's going to help illustrate my point. Now what I'm going to do is I'm going to multiply every single observation by some number whose absolute value is greater than 1, which means I could multiply by -3, right? It would flip my distribution around a little bit. So I'm going to use a positive number because I think it's easier to work with. But I just want to know what's going to change. So let's multiply everything by 3. It should look the same, but instead of 6, this is now 18. Instead of 4, this is now 12. Instead of 2, this is 6. This is still 0 because math. And this is -6. So what I hope you see first of all is the physical center of this has definitely moved, right? The median is no longer 2. It's 6. So this definitely changed. Number 2, we're definitely going to say change. Check mark, however you're feeling about it. I also want you to remember when we have a density curve like this, and if it's roughly symmetric, which is what I attempted to draw, I just didn't get there, the mean is in the same location as the median. So if the median changed, the mean changed, right? Also, if you think about it, it's centered at a completely different number. The mean and median are both measures of center. They should both be changing. Standard deviation, remember that's how spread out the data is. I kind of drew this really terribly, but look, it goes from -6 to 18, and this one goes from -2 to 6. It's more spread out. That means the standard deviation increased. So in fact, all 3 of those sample statistics increased when we multiplied those data points. All right, let's do another one. The histogram below displays the frequencies of waiting times in minutes for 175 patients in a dentist office. Which of the following could be the median of the waiting times in minutes? All right, so there's a lot going on here too, but I see I want the median. I know that there are 175 patients. I find it interesting that they use the word could. We'll talk about that in a little bit, and something I can help you keep an eye out for when we're doing FRQs. But I want the median, and there are 175 patients, and I don't have any of the data, right? I've got a graph that kind of shows me the data, but it doesn't really show me the data. So this goes back to that thing I was saying on the measures of center page. What I'm going to do is I'm going to find out what 175 divided by 2 is. And it turns out that that's 87.5, which means the median should be at the 88th observation. Okay, the median is the 88th observation. So I need to figure out where the 88th observation is, the ordered 88th observation. Look, in this one right here, don't I have 80 of the observations? Well, the 88th is probably somewhere in this one, right? It has to be. So which of these could be the median waiting time in minutes? Well, 2.5 isn't between 5 and 10. 7.25 is. So that's why they say could be. If they put 6, I wouldn't have had any reason to not pick that. 6 is between 5 and 10. All I know about the median is it's between 5 and 10. So, but they made sure that none of these other ones were between 5 and 10. So that was good. All right. Of the following dot plots, which represents the set of data that has the greatest standard deviation? So greatest standard deviation, I'm trying to think which one is the most spread out, which has most of its observations far from the center. Well, this one's pretty evenly spread out, right? This one right here. It's pretty evenly distributed. So it's probably not it. This one, it's centered right here, right? Because it's symmetric. And most of the data is far from it. So I'm kind of eyeing that one. C has more data in the center. So if there's data at the center, it's not spread from the center. Same here. And same kind of thing here, right? So this one has most of its data away from the center. So I'm going with B for my answer on that one. The one that has most of the data far from the center. All right, very last thing. A random sample of 374 United States pennies was collected and the age of each penny was determined. According to the box plot below, what is the approximate interquartile range IQR of the ages. So remember, the box plot starts starts at the minimum, goes to the maximum. This is an outlier. We'll talk about this graph more in the next video. Right here, the start of the box is Q1. The vertical line in the middle, or I guess it's horizontal this time, is the median. And this is Q3. IQR is Q3 minus Q1. So we just need to estimate that. That looks like it's 18. And that looks like it's 3. So we'll say about 15. That's it. That's one variable statistics, at least part 1. We'll be doing part 2 whenever you turn it on.